And for another amazing riveting video by Mrs. Dushin, here we are. Expression packet pages 22 and 23. We are going to talk about the concept of factoring. So before we get into factoring expressions, we just want to warm up and make sure everybody remembers how to find the greatest common factor, or the GCF, of two or more numbers. So remember, a factor is a number that divides into another number with no remainder. So we start with number 1. We're looking for a number that divides into both 3 and 15. And it's not any number, it's the largest number. It's the greatest common factor. So the largest number that goes into 3 and 15 is in fact the number 3. For number 2, the greatest common factor of 36 and 28. Now, 48 have lots of common factors, but remember, you want the greatest. If you're not great, no pun intended, at figuring this out, what you can do is list all the factors of 36, maybe over here, and list all the factors of 48. You can use your calculator for that to help you, and then pick the number, the largest number that's in both sets. Okay, at this point, we should be comfortable with these numbers, though, and the greatest common factor is 12. For number 3, greatest common factor of 6 and 18a. Now, I've thrown a variable in here, but here's the thing. If there's no a over here, then there's not an a in common. So you can basically just ignore it. You don't even need to worry about it. And we're talking about the GCF of 6 and 18, which is 6. Again, same kind of thing for number 4. I have an x over here, but I do not have an x here. There is no x in common, so the GCF of 5 and 10 is 5. For number 5, again, C here, but no C here. So now we're looking at 9 and 27. The GCF is 9. However, if there is a negative in common, then we want to pull that negative out and make our GCF negative 9. Even though positive 9 is greater than negative 9, we want to pull out anything that's in common to both of our terms. Okay? So that same thing applies here for number 6. Negative 100h and negative 15. They're both negative, so let's pull the negative out first. Now, this one has an H, this one doesn't, so we don't need to worry about the H's. And the GCF of 15 and 100 is 5. Okay? All right. So now we're going to take that idea and bring it into factoring expressions. What I want you to write here, right underneath factoring expressions in capital letters, what we're doing is distributing. Factoring and distributing are opposites of each other, just like addition and subtraction, multiplication and division. They undo each other. So distributing and factoring undo each other. Okay, so that's what we're doing. Keep that in mind. So our first example here says factor 2x plus 6. Okay. So step 1 is find the GCF of 2x and 6. The GCF of those is 2. Now step 2, write the expression as a product of, remember, product is multiplication, of its GCF, which in this case is 2, and the remaining factors. Okay, so watch how I do this. I'm going to do this over here. Okay, we have 2x plus 6. So what we're going to do is we're going to take the GCF and we're going to divide, because remember, when we distributed, we multiplied. Well, because this is undistributed, we're going to divide each term by the GCF. Okay, so this is you showing work. We take that 2, that's the GCF, and we bump it out. And what we have left when we divide in this case would be x plus 3. And that is our final factored answer. Okay, so this guy and this guy are equal. These are equivalent expressions. Notice This was our original. This is our factored. If I want to check and make sure my factors form is correct, I could redistribute the 2 back in and make sure I go back to my original expression, which was 2x plus 6. And in this case, we do. Okay? All right, let's practice. Go to page 23. Number 1, here's our expression, 3x minus 6. The GCF, in this case, is 3. Okay? So now I'm going to write my expression, and I'm going to divide each term by the GCF. And then I kick the GCF out. Okay, it's important that you do that right away because a lot of students will forget to put that GCF on the outside of the parentheses. Now, 3x divided by 3, the 3's essentially cancel out. I'm left with x. My negative is going to come down, and 6 divided by 3 is 2. So here is my factored answer. Okay, let's do some more. Number 1. This is the same thing except it's 3x plus 6. So I think this is going to be pretty straightforward. The GCF is 3. So we're going to divide each piece by 3, and we're going to kick the 3 out. 3a divided by 3 is a. I bring down the plus sign, and 6 divided by 3 is 2. I'm going to move down. Number 3, the GCF. Now, they're both negative, okay? So we're going to start with our GCF being a negative. Only this one has an H, so there's not an H in common, so we don't need to worry about that. So the GCF of 6 and 24 is 6. So we're going to divide each term by negative 6, and then we kick the negative 6 out. Negative divided by negative is a positive. 24 divided by 6 is 4, but then we have to bring down the H. Negative divided by a negative is a positive, and 6 divided by 6 is 1. Okay, final answer. Number 5. There's only one negative here, not here, and there's only one variable here, not here. So we don't need to worry about the negatives or the variables. So now we just got to figure out the GCF, the largest number that goes into both of these. Well, 22 does not have a lot of factors. 1 and 22 and 2 and 11. And 2 goes into 36, so our GCF is 2. So we just divide each piece by 2, kick the 2 out. Negative 36 divided by 2 is negative 18. Bring down our plus, and then we have 11m. Final answer. Okay. I want you to pause your video, try numbers 2, 4, and 6, see how it goes, and then unpause and check back to see how you did. Go ahead. Okay. Number 2, the GCF here is 2. We divide each piece by 2. We kick the 2 out. We're left with 7x minus 8. Number 4, this one's a little tricky because the GCF is actually 18. 18 does go into 72. Okay? So we divide these. So I'm going to kick the 18 out, and I'm going to show you something in just a second. Over here, we get P. We bring down the plus sign. And 18 goes into 72 6 times? No, that's not right. 5 times? 4 times. 4, 2, 3. Yep, 4 times. So there's our simplified answer. And for this number 6 here, our GCF is 4. We kick the 4 out. Our first term becomes 3y. We bring down the negative, and then we get 2z. Okay? Now, I want to go back to this one for a second because a lot of students look at 18 and 72, and they think the GCF is 9. Okay? So let's say that you were one of those students, and you thought the GCF was 9, so you did this. Okay? 18p divided by 9 is 2p, and 72 divided by 9 is 8. Now, this isn't wrong, but you're not done. Because when you look inside your parentheses, there is a number, a common factor still between the 2 and the 8. So because you can essentially keep going, you're not done yet. You got to go again. All of these other ones, there is no common factor left from what's inside the parentheses. There's nothing in common between 18 and 11. Nothing in common between 3 and 2, okay? But there is something in common with the 2 and the 8, and that's a 2. So now we're going to do this again. Watch what happens. So I'm going to divide each of these by 2. I'm going to kick the 2 out. But guess what? The 9 is already out there. So when we divide this, we get P. 8 divided by 2 is 4. The 2 times the 9 is 18. And do you see how we got the same final answer, but this took us 2 rounds of factoring to get there, whereas this one only took 1. So that happened because we didn't divide by the greatest common factor. We just divided by a common factor. So keep that in mind. Once you divide, look at what you have left inside the parentheses and make sure that there's nothing else that's still in common that you can't keep going. Okay? All right, everyone, again, and remember that to check your work, you can always distribute that number, that GCF, into your terms inside the parentheses to try to get back to the original to make sure it's correct. That's your check, okay? All right, as always, email us for help, go to the math support, or rewatch the video. Okay, have a great day, morning, afternoon, night, week, whatever. Peace.